Hi students, these are your scientific method notes. You need to complete the note-taking guide that you picked up in class, and then also complete the qualitative, quantitative observation worksheet you picked up also. Okay, scientific method. First of all, science is the study of the natural world using observations and experiments. The basic steps used by scientists in solving problems and uncovering facts is called scientific method. There are 6 steps to the scientific method. The first one is to identify the problem. Next, research past knowledge. Next, you'll create a hypothesis. Design and perform an experiment. Record and analyze your data that you collected during the experiment. And from that data, you will state a conclusion. And it's important in your conclusion that you either confirm your hypothesis and that it was correct, or you reject it. Basically, you prove that what you predicted was not correct. Let's go back up here to the problem. Very easily, the problem could be a question. Please do not think that a problem is something that has to be wrong, like, oh my goodness, this is a problem. No, it could easily be a question that you have. In order to know, in order to be able to make some kind of a prediction, you're going to have to do a little research about the question or the problem that you're addressing. You're doing the research so you can create an educated prediction. Really, I think the best definition for a hypothesis is a testable prediction. This prediction should always be written in an if-then statement. We'll talk more about the hypothesis in a little bit. Your experiment will always include 3 parts. It will be the materials list, procedure, steps of the procedure, and data collection. I'm going to abbreviate it. Data collection in the form of tables. Your analysis will always end up being some type of a graph, some visual depiction of what your data collection involved, and then you're going to, of course, have your conclusion. To conduct an experiment, you must create a hypothesis. A hypothesis, you probably have learned, is an educated guess. However, again, I think that testable prediction is a lot better definition. It should be written as an if-then statement. The procedure will be the steps that you follow during the experiment. Data will be your recorded observation or facts. Of course, you're doing the experiment in order to produce data that you can collect. And then finally, what was the conclusion? At the end of the experiment, the conclusion is made to either confirm or reject the hypothesis. Again, confirm means it may be correct. Reject means that the hypothesis is definitely not correct, and you may have to change your hypothesis and retest. The conclusion is based on the data collected during the experiment. I want to go back up here to remember the steps of the scientific method. I know this is going to sound real silly, but sometimes silliness allows us to remember things easier. And so I want you to write the first letter, P for problem, R for research, H for hypothesis, E for experiment, A for analyze, C for conclusion. P-R-HEAC. 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 In class, I may even ask you, okay, guys, I want you to write out the P-R-HEAC. Okay, that's what I'm talking about, the steps of the scientific method. So come to class prepared to pronounce this silly word here to help you remember the steps of the scientific method. All right, let's go back down to Roman numeral 4. A variable, let's talk about the experiment. A variable is a factor that can affect the outcome of an experiment. Let me give you an example. If you were doing an experiment about the growth of a plant, whether it is in the sun or not, the only way that you could do that experiment is to stop and think about, I'll wait, about the variables. What are the factors that could affect the outcome of the experiment? Well, the type of soil, the amount of watering, the type of plants, the fact whether you use fertilizer or not, is it in the sun or in the shade? These are all variables. These are things that could affect the outcome of the experiment. Now, when you do an experiment, you can only test one variable at a time. All of the other variables have to be kept the same. What that means is that they must remain constant. Okay? So constants, or constant variables, are all the variables that are kept the same throughout the experiment, so they will not affect the results of the experiment. For example, if you're testing whether a plant grows better in sunlight or in dark, you would put a plant in the sunlight, put a plant in the dark. Both plants, however, would have to get the same amount of water at the same time of day. They would have to have the same type of soil. It would have to be the same kind of a plant. You would have to fertilize them the same, so that if there is a difference between the one in the dark and the one in the sunlight, you know without a doubt that it is a result of the sunlight versus the dark. All of those variables that will be the same in your two setups are called constant variables, or constants, because they constantly stay the same. Okay, flip the page. Now, the variable that you are going to test, it is the variable that the experimenter changes, so that you can observe the results of the experiment. Sometimes they're even called the experimental variable, is called the independent variable. So of all those variables that could affect the outcome, all of them have to remain the same except the one you're testing. The example I've given you is plants in the sun versus in the dark. So our independent variable, what we have control of, what we're truly running our test about, is a plant in the sun versus a plant in the dark. That is our independent variable. There's a quick little way to remember this. Mix. I personally don't use this. It is the manipulated variable, meaning you control it. It is an independent variable, and it goes on the x-axis when we start talking about graphing. Guys, there can only be one experimental variable. Remember, all of the other variables must remain constant in both of your setups. Next, you're going to have the dependent variable. Now, guys, listen to the wording here. The dependent variable is what's being measured. Okay, for example, our plants in the sunlight and the dark. The independent variable, our test is about putting a plant in the sunlight and the dark. Well, how much it grows is going to be our measurement of our independent variable. Think of it this way. The dependent variable depends on the independent. The amount the plant grows depends on whether it's in the sun or the dark. The amount the plant grows must be the dependent variable because it depends on whether the plant is in the sun or the dark, which remember was our independent variable. Quick way to remember this, dry. Dependent responds to the independent variable, plot on the y-axis. Again, I don't even use that. Roman numeral 5, observation. I thought I was messing up there. An observation is making sense of something by using your 5 senses. Any observation that involves measurement or numbers is called quantitative. Quantitative, not quantitative. Quantitative, notice it has the beginning of quantity in it. A qualitative observation is any other observation. It has nothing to do with numbers or measurements. When you take what you know, your observations, and you try to explain them, you are doing what is called inferring. You are making an inference. An inference may or may not be correct. Observations, people can't really argue about it. It's raining outside. Nobody can argue about that. But if I say it's raining outside, I bet they're going to cancel the ball game tonight. Okay? That's making an inference. That may or may not happen. Okay, notice the examples here. George did not do well on the test. Well, that's easy to observe by looking at his score. But for somebody to say, George probably did not study for the test, that is making an inference. Moving on, the expected outcome of a future event. No observations needed. I predict if students study for the science test, they will do well. Okay? What is that going to be called? The expected outcome of a future event is something we've already used, but we can think of it another way. Really, you create this before you make your observations, and that's going to be your hypothesis. Lots of importance on the hypothesis. The scientific method is not a step-by-step process. It is flexible in that it often changes as information is gathered. This is a really good diagram here. That's it. I hope I cut this and made this under 10 minutes.